Today we are going to talk about compositions. And you've talked about compositions before, but with functions. Now we're going to just talk about trig compositions. So we're going to see how do we simplify a composite trig expression that includes ratios and includes angles. So this is the first type of problem you're going to see. It's going to say secant the inverse sine of some blah, 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 some ratio right here. Remember, if it has this little -1 up here, this means that we're really looking for some angle measure. So we're looking for a theta, whether it's in degrees or radians. And so my first step that I'm always going to do here is I'm going to draw a triangle. So if I draw a triangle for this first one, I'm just going to be looking at, since it is positive, wow, I should have drawn my quadrant first. So since it's a positive sine value, we know we're in quadrant 1. And so sine is going to be opposite over hypotenuse. So we have 5/7 is my hypotenuse. So when I look here, I can go ahead and use the Pythagorean theorem in order to find that missing side. So we're going to find the missing side. Missing side, and we're just going to use a squared plus b squared equals c squared. So I'm missing one of my legs, so I'll just go ahead and call that a. And so I would have a squared plus 5 squared, again, if it's negative, make sure you put in parentheses, equals to 7 squared. So if I go ahead and simplify this down, I get that a squared is equal to 49 minus 25. It's going to be 24. So I'd take the square root of both sides, and I know I could simplify down 24 a little bit. It has 4 and 6 as factors, so I know that a is equal to 2 root 6. So a is equal to 2 root 6. So what I've just found here is I've found this angle that made this particular triangle. And I don't know what this angle is, but it doesn't matter because what I need to find now is I need to find the secant of that angle. So once I've gone ahead and I found that missing side, then all I have to do is find the new ratio. So if I look in here, secant of theta, secant is the opposite of cosine, so I'm going to be looking for my hypotenuse over my adjacent side. My hypotenuse on this is 7. My adjacent side is that new side that we found, so 2 root 6 or square root of 24, and that would be your answer. So when I look at one of these, the first step that I always do is I'm going to try to draw a triangle, however that needs to work out. So you're going to have to remember your SOHCAHTOA. I know that's shocking to you that we just have not lost SOHCAHTOA yet. And then we're always going to work from the inside and then out. So we're going to start with my first set of parentheses, deal with what's going on in there, and then we're going to go back and figure out what that outside is. So what I want you to do is, using those steps in green, I want you to go ahead and try this one. Now remember, if you have something that says arc, like for instance this one says arcsecant, I want you to make sure that you know that this is the inverse secant of whatever, and this shouldn't have a theta. I have no idea what's going on that. That's silly. Okay, so we'd have the inverse secant of -3/5, over 2. I can't even read today. Struggle is real. And then we're going to find the cotangent of that particular triangle. So go ahead, pause, figure out what that's going to be. Hopefully you paused. And your answer for this one should be -2 over the square root of 5. Make sure you've drawn into the right quadrant. Secant's going to be in quadrant 2, so your triangle should be over here. Your hypotenuse will always be positive, and then you're looking for your missing side. Okay, the other type of composition you might see looks like this one, where it says sine of 4π/3, and then it has the inverse on the outside. So they've already given you the angle here. 4π/3 is an angle. So what they want you to find here, they need you to find a ratio. So you're going to find something over something, some fraction-y type number. So your first step here, we're still going to be drawing a triangle, but first we need to draw the angle that's inside there. So if I look here, 4π/3, here would be 3π/3, and this would be 6π/3. So 4π/3 has got to be over here in quadrant 3. Okay, then what I'm going to do is I'm going to go ahead and find that exact value of that particular angle. And so we know when we're finding an exact value, the first thing we need to do is find my reference angle. So my reference angle here would be pi over 3 or 60 degrees. Then I'm going to go ahead and fill in the ratios for my special right triangle. So I know my hypotenuse should be 2. Opposite the 60 is going to be your root 3. And because this is down and be negative, then we have my other side would be 1. And again, it's negative because it's to the left. So since I'm looking for my sine of 4 pi over 3, that would be my opposite, negative root 3 over my hypotenuse. So now I figured out what's on the inside. So I know that this whole thing right here is equal to the negative square root of 3 over 2. So once I have that ratio, you're now going to find that new inverse value. Okay, and when you're finding an inverse value, you're going to be looking for a principal inverse value. Since they didn't give you a range to go through like 0 to 2 pi, you're just going to find the one answer, that principal inverse value. So since I have all this done, I'm actually going to be finding the inverse cosine. Sine of 4 pi over 3 is the square root of 3 over 2. And so on this one, you might have to draw another triangle. So I know since I'm looking for the principal inverse value, cosine, inverse cosine goes between 0 and pi. So my negatives should be in quadrant 2. So I'm going to draw that angle out. My cosine is my adjacent over my hypotenuse. So if I fill in things I don't know, it'd be 1 right here. My reference angle is 30 degrees. And again, I have to be in quadrant 2. So I would be something pi over 6. I would be 1 pi away. So 5 pi over 6 would be my one answer for this one. So again, you will have to remember your principal inverse values as far as the restricted ranges are in order to find these compositions. So we drew our first angle from the inside. We found that ratio. We plugged it back in to find my new principal inverse value. So you have to draw 2 triangles on this one. So go ahead and use those steps in blue in order to find the inverse sine of the cosine of 3 pi over 4. Okay, go ahead and pause. Try this. Okay, you should have gotten the inverse sine of negative 1 over root 2, and that principal inverse value would be negative pi over 4. Okay, last thing we need to talk about is what happens when we have things like this. So the hardest part about the compositions is realizing what they're asking for. Again, if you have an inverse function where it says, trig to the negative 1, that's looking there for an angle measure. So you are looking for some angle. If it's just a regular trig function where it just says, sine, cosine, tangent, then you need a ratio here. So if I'm looking at this one, this is tan of 0. So this is giving me an angle measure. That's an angle in there, and I'm trying to find a ratio. Okay, it's a regular trig function. I want to know what is the tangent of 0 degrees or 0 radians. So I can either use my unit circle or I can use my OIO chart. I feel like I should just have this on every slide because I have to rewrite it every time. So SOHCAHTOA 0 pi over 2 pi 3 pi over 2. So if I look, again, this isn't an inverse, so I'm not looking on the inside. I know I'm looking for a tangent, and I need a tangent of 0, and that just happens to be 0. Okay, so what I'm really looking for here is the inverse cosine of 0. So now at this point, inverse cosine of 0, this is giving me, I want an angle out of this. Okay, I need an angle. This was my ratio, so I'm going to work inside my chart to find this. So I'm going to look and see, okay, well, it needs a different color. So if I'm looking for a 0 on my cosine column, well, I have one here, I have one here. So I have to remember that cosine goes from 0 to pi, the inverse cosine. It's in quadrants 1 and 2. So I'm going to forget about 3 pi over 2, and I'm going to pick pi over 2 as my final answer. And that's all I got about compositions.